Okay, welcome. This is track day, and I'm recording it for all of you track people who are just running. What are you doing, right? Pass the baton, pass the baton. Huh, 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 right? Or I'm doing it for those of you doing the javelin. Woo! Or shot put, right? That's how you do it. Right there on the neck, right? Right there on the cheek. What else we got? Hurdles, right? You go track, you go. Oxnard! No. Oxnard! Yellow Jacket! Right? Is that what we are? I wasn't even recording. What are we talking about? Track. We're actually talking about graphing rational functions, holes, discontinuities, and asymptotes. Okay, all right. So, graphing rational functions, holes, discontinuities, and asymptotes. Discontinuity is basically an asymptote in a hole. It's where the graph stops, right? The asymptote doesn't continue, right? Anyhow, and the hole, well, I'll explain what a hole here is in just a second. Okay. We know what an asymptote is. The asymptote is where this is discontinuity, and then the hole, it's going to be a circle that is infinitely small. That it's just infinitely small, but it's a hole. It doesn't exist. It shows up on the Desmos calculators too. The discontinuities for this are x is, we list it as x. X is negative 0.5 and x is 0, because this is where the discontinuities are. And that's how you're going to list it. Give me confused looks if you understand. Okay, good. That's great. Anyhow, let's move on. So, here's our first problem that we're going to do. Okay, I'll let you guys get set up for this. Here we go. So we're going to graph this rational function. What do you guys notice about this? Yes, Isaiah.
Is it that there is an x-intercept with the asymptote?
There's an intercept. There is an asymptote. But yeah, that's not what I'm particularly looking for. What else do you notice about this? So yeah, that is something to put out that we have asymptotes 7 and negative 3. But something else we notice about the numerator and the denominator. What do you guys notice about the numerator and the denominator? You can cancel out an x plus 3. You guys see how you can cancel out the x plus 3? So we're going to cancel that out, and we're going to have a new equation here. We have a new equation, x plus 3 over x minus 5. My new equation, which I cannot fit, but I'm going to write it right here, is going to be f of x equals now x minus 5 over x minus 7. This is the function we're going to graph right now. We're going to get back to this in just a second. So, see if I can flip through here. I have f of x equals x minus 5 over x minus 7. Let's see if we can put all our information on a new file, new flip chart. So my new function is going to be, well, our original function was f of x equals x plus 3, x minus 5. X plus 3 times x minus 5 over x minus 7 times x plus cancel out the x plus 3. So the function we are going to graph is going to be the x minus 5 over x minus 7. Okay, so we're going to graph this right here. Now, that's what we're going to graph. So let's go with our steps. First step, set equal to 0. Second step, factor. So let's do that. 0 equals x minus 5 over x minus 7. Pretty simple. It's already factored. Next step, what are my zeros for the function? What are my zeros? X equals positive 5. The zeros are in the numerator, right? The zeros are, right? X minus 5 equals 0. You add 5 on both sides. What are my asymptotes? Positive 7. I got Isaiah's with me. Anyone else with me? Let's see, I'm going to start calling people's names. We get x equals 7 is the asymptote. X cannot equal positive 7. Okay. Another thing. What is our horizontal asymptote? Talk about it in your groups. What is a horizontal asymptote? I'm going to call one of you. What is a Remember, for the horizontal asymptote, I want my m and n. M and n. What is my exponent for this one? 1. What's my exponent for this one? 1. What do I do if m equals n? Sophia, what is my horizontal asymptote? Y cannot equal 1. You take the coefficient in front of this, divide by the coefficient over that, which is 1 over 1, which is 1. Okay. So, we have our asymptotes. We have our 0. We have our vertical asymptote. We have our horizontal asymptote. Let's test the intervals, shall we? So, let's go like this. Doot, 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 doot. What numbers do I need? 5 and 7. Blink, 5, blink, 7. It's going to be hard flipping it back and forth. 5. Devin Alicious, give me a number less than 5. 4. 4 minus 5 is negative 1. 4 minus 7 is negative 3. 2 negatives make a positive. Am I going too fast? Jocelyn, give me a number between 5 and 7. 6. 6 minus 5 is positive 1. 6 minus 7 is negative 1. 1 negative is a negative. Not here. Isaiah, give me a number bigger than 7. 1,000,000. Positive, positive, positive. Okay, so we got that. Okay, here's where the new thing comes in for us. Notice the x plus 3 over the x plus 3 is eliminated. If I was to graph this, though, if I didn't eliminate it, what would be confusing is that I have negative 3 as a 0, and I have negative 3 as an asymptote. So it freaks out. Mathematically, that freak out turns into a hole. So the hole is going to be this. We'll call it a hole. The hole is going to be x is 3. That's my hole. How do I figure out the y? Plug 3 into what? Caesar, what do you think? Oh, during my filming, Caesar corrects me. Does it in a polite way, but it makes me look bad. Caesar corrected me. It's x equals negative 3, because negative 3 plus 3 is 0. Anyhow, thank you, Caesar. But what do I plug negative 3 into? What's that? I'll give you a choice. This equation or this equation? Which one? This one. Plug in negative 3. Go ahead and plug in negative 3, see what you get. Plug it in. That'll give us the whole. We'll go here, negative 3 minus 5 over negative 3 minus 7. Negative 3 minus 5 is negative 8 over negative 3 minus 7 is negative 10, or 8/10, which reduces to 2/3, which is 0.8. 2/3. That's going to be my whole. What did I do wrong, Caesar? I can tell by your look. 2/3. No, don't say it, Caesar. Get away from me. Sorry. Let's go back. Let me start over again. Wait. Reducing fractions. They're both divisible by 2 4/5. 4/5. I'm going to be demonetized. You guys with me? 4/5. Okay, so that's going to be our whole. We have all this stuff. Just get our random points. Let's get our random points. X, Y. So we got to pick a point in between each of these. So let's pick a point less than 5. No, wait. How do we want to do this? Pick a point in between each asymptote. So let's pick 0. I'm going to do 0. I'm going to do 6, and I'm going to do 8. For 0 for here, 6 for there, 8 for there. So then let's plug in those points, and then we can get that. Then we have everything we need for our graph. Okay? So plug in 0. 0 minus 5 is negative 5 over negative 7. So that'll be 5/7. 6 will be 6 minus 5 over 6 minus 7, which is 1 over 1. Negative 1, which is negative 1. Let's check. Caesar, is that right? Yeah. All right, thank goodness. Okay, negative 1. And then 8 minus 5, plugging in 8 into my equation, over 8 minus 7. Oh, that's a nice one, which is 3 over 1, which is 3. Caesar? Yes. Okay, so these are my random points. 0, 5/7, which is close to 1, a little bit less than 1. 6, negative 1, and 8, 3. I think we have everything for our graph. You guys have all that? I'm going to have to flip back and forth as I graph this. But let's do it one at a time. Let's see. First, let's label our graph. We have here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, one thing at a time. Sorry, I'm flipping back and forth. We have here what first? Our 0. X is 5. So let's put that in. We got X is 5. I'm going to do my zeros in blue. My graph in blue. I got X equals 5. There's my 0. I got that right there. No problemo. Next, I got my asymptote. X cannot be 7. So I'm going to go to 7. I'm going to do my asymptote in blue. 5, 6, 7. I got it right here. There's my vertical asymptote. What else do I got? I got my horizontal asymptote is positive 1. So I'm going to go here, my horizontal asymptote at positive 1. Actually, I only need to do here and here. I didn't need to do in between that and that. That's fine. Let's do our random points. I got 0 and 5/7 as a random point. Do that in blue. 0 and 5/7, which will be right about here, approximately a little bit less than 1. I got 6 and -1. 1, 2, 3, 4, 5, 6, -1. I got that point right there. Am I going too fast for anyone? Raise your hand if you need me to slow up. Slow up? Need me to slow down? Okay, you're just correcting me. What would I do without you guys? I get so many corrections. Okay, 8, 3. Over 8, up 3. I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. I got an idea of what this is going to look like. Let's do our whole. So we got to get the whole. Remember, the whole is -3 and 4/5. So here's how I do the whole. -3, 1, 2, 3, 4/5. Going to be close to 1. You just do a little circle there. There's my whole. I think you guys can see what the graph's going to look like without checking the intervals. But between negative infinity, less than 5, what do I got? Less than 5, I got a positive, right? Which makes sense. So I'm going to be positive. I'm going to go here. Stay above, right? See how I'm above this, but I'm below my intercept. And I'm going to go here. I'm positive, go through that point, and then I go there. Boom. What's going to be after 5? Probably negative. Between 5 and 7, I got a negative. Okay. 5 and 7, negative. Go through that point. You can't hit the asymptote. You go like that. And then after 7, you can probably tell, as I can see, it's going to be positive. And so you go like this, you go like this, you go like that. Do. All of that. But wait, there's more. You guys hate it when I say that? Because on the test, to be honest, you're going to have to fill these out, which you already have the information, right? But on the test, you're going to have to identify the vertical asymptote. What is a vertical asymptote? X cannot be 7, right? What's my whole? What was it again? -3 and 4/5, wasn't it? Whole was -3 and 4/5. What's my horizontal asymptote? Y cannot be 1. And my discontinuities are all my x's that cannot be. X cannot be 7 and -3. I'll say -3 and 7. And that's all you got to do. You know, it's kind of a pain. What's nice about this one is it's factored already. Sometimes you're going to have to factor them and then figure out if there's going to be a hole. But nonetheless, if you know how to factor, it's no problem. I'm just going to... All right, here we go. Graph f of x equals x cubed minus 9x, 3x squared minus 6x minus 9. Let me go ahead and write that out. x. Okay, so our first step is going to be to set equal to 0 and factor. So here we go. I am going to factor it first. Instead of x cubed minus 9x, I'm going to factor out an x and say x squared minus 9. For my numerator, denominator, what's my greatest common factor there? 3. So I'll say 3 times x squared minus 2x minus 3. You guys see that there? But I have to continue factoring it. So I'm going to set it equal to 0 and say 0 equals x times, this is a difference of squares. X squared minus 9 will be x plus 3 times x minus 3. Let me know if I need to explain that. This, if I factor it as a diamond, will be x minus 3 times x plus 1. Whoopsie. Dude. Then I can see that the x minus 3 cancels out. So what does that mean my whole is going to be? X cannot be 3. So it's going to be 0 equals x times x plus 3 over 3 times x plus 1. So this is what we're going to graph. Is that right there? We're going to graph that. Hey ho, hey ho. What are my zeros? In the numerator, what are my zeros? I got negative 3, and there's one more. 0, right? This x equals 0 is a 0, right? Negative 3, because negative 3 minus plus 3 is 0. 0 is 0. So I got, my zeros are negative 3 and 0. My vertical asymptotes are going to be what? There's only one. What, Devin? Negative 1. My horizontal asymptote, well, oh my goodness. This is an ugly one. What do I have? M is equal to n, m is less than n, or m is greater than n? M is greater, because x times x is x squared over x. So to find those asymptotes, I'm going to factor this out. X squared plus 3x over 3x plus 3. Notice m is bigger than n, so it is not necessarily a horizontal asymptote. It's going to be a slant. So the slant, what do? Synthetic division if we can, but because this is a 3x plus 3, I'm going to have to use the regular division. Okay? So I'm going to do. So to find the slant, I'm going to have to divide this divided by this. I multiplied this out to find the slant. Now I'd like to use synthetic division. However, because there's a 3 here, I can't use synthetic division. So I'm just going to use regular division. And I'm going to do x squared plus 3x divided by x plus 3. And here we go. I might need your guys' help on this. What times x equals x squared? Whoops, what do I have here? This is supposed to be 3x plus 3. There you go. Sorry about that. What times 3x equals x squared? 1/3 x. 1/3 x. How do I get that? Because 1/3 times 3 is 1, and x times x, which will be x squared. 1/3 x times 3 is plus 1x. Because 1/3 times 3 is 1, right? I'm going to subtract, and then I'm going to do the skip change, plus negative. That becomes 0. This becomes now 2x. plus 0. What times 3x equals 2x? What number times 3 equals 2? Right? So what number times 3 equals 2? What number times, see, I put n is going to be my number. Solve it. How do I solve for n? Divide by 3. And it's going to make sense. It's going to be 2/3. 2/3 times 3 is going to equal 2. Because it makes sense, because they're going to cancel out. So I'm going to say here plus 2/3. 2/3 times 3x will be 2x. 2/3 times 3 is equal to 6 over 3 is equal to 2. 2/3 times 3 is going to be plus 2. I'm going to subtract, and I get a remainder of -2. But that doesn't matter. I don't need the remainder for my slant asymptote. What I do need, though, is my slant, which is going to be this in this form. Y equals 1/3 x plus 2/3. There's my slant asymptote. Y equals 2/3 x plus 2. Y equals 1/3 x. 1/3 x plus 2/3. So I have to graph that line to be my slant asymptote. We'll get into that in just a bit. But does anyone have any questions on that? I plug in -2. I got, wait, yeah, -2 times 1. You get 2/3 for both of them? Well, let's see if it works out. You know it's right when you hit the graph. You guys ready? We're almost done. You guys good with that? Feels like all the positive energy left. Because Nathaniel left. He was all our positive energy. All right. What do you guys think? You guys want to work on it? If you have questions, let me know. That was kind of a thing.